Hello, I'm Jeddy Ruiz, call sign Bronco, and I did serve in the United States Marine Corps. And in fact, I did fly in the OV-10 Broncos and also the A-6B Prowlers. And currently, what I'm doing is I'm serving as an instructor for the Escambia County School District at the Flight Adventure Deck.
Okay, here at the Flight Adventure Deck, you can see me working with some of our 6th graders. Hard-charging 6th graders, the Bailey Bulldogs. And in fact, one of the students, Colley's his name, who you see me giving a fist bump to. That was the second time there. First time he came there with a Workman Middle School. He loved it so much, wanted to come back a second time. Now when I'm not there, I'm over at the
National Flight Academy. But anyway, welcome to Naval Air Station Pensacola. And what you see right now in back of me is the F-18 Hornet. And what I want to do for you today, though, is go over a few things with y'all. We'll keep this nice and fun, and which what I'll do is I'll go over a brief history of the F-18 and also the Blue Angels. And what I will also do, though, is cover a little bit of some math and science standards and also some engineering standards, which you can expect on any kind of flight or aerospace exam. Let's keep this fun, give y'all some fun facts as far as just a part of my experience. The F-18 Hornet, it is a fighter attack aircraft. It did replace some aircraft, such as the A-6 Intruder. One movie that the A-6 Intruder was in was Flight of the Intruder. It also replaced the A-7 Corsair. The F-14 Tomcat, which is in Top Gun 1 and 2. Someone who I served with, Marco Cromartie, an instructor at BT-86. I was one of the flight students. But anyway, he got an opportunity to serve as an extra in the movie Top Gun, which you can see right here in some of the pictures. Anyway, those are some of the fun facts. The Blue Angels have not always flown the F-18 Hornet.
And prior to flying the F-18 Hornets, the Blue Angels flew the A-4 Skyhawk, which you can see right here in this clip. And in fact, it had the nickname of Tinker Toy. Now, I did have the opportunity to be trained in the TA-4, which is a two-seat training aircraft, the A-4, when I was at the training command. Fun airplane.
A few of the standards before we do the walk around on the F-18. Aviation does have a lot of math, science, and also engineering that's involved. We'll go over is at altitude and also air pressure. And graphing, which is certainly a mathematics standard, and you'll see that as related to altitude and also air pressure.
We will now cover an engineering standard, which is about materials that are used within the aerospace industry, which also has much relevance to science. We will have a fun hands-on activity by walking around, examining, and touching all the various materials and surfaces of the aircraft.
Before we get up close, as you can see the nose of the aircraft, the pointy end over there, off to the right of your screen. Then you see the front nose wheel, as well as the cockpit, which is where the pilot would sit. And then as you go along, you will see the fuselage, and then the wings, and then the vertical stabilizer, which you see the number 1 on. And by the way, the Blue Angels, the way how they're numbered is everybody has a number. 1 is the boss or the commanding officer. And you see the exhaust in the back.
You also see the landing gear where you see the tires.
As you look on this diagram, you will see that this aircraft is made out of many different materials. A few are aluminum, steel, titanium, and also graphite epoxy, as well as other. And we'll go over some reasons on why they may end up using different materials. We see the nose cone up close and personal.
The nose cone is made of different materials. Aluminum is used throughout various surfaces of the aircraft, such as the fuselage and also the wings.
Now, one thing which I would like to ask you all is to let us know, why do you think aluminum is used instead of something like iron?
We will go over two items which you can see are extending from the fuselage. On any exam which is flight related or aerospace related, you are expected to be able to explain what these items do and how they function.
This right here is the angle of attack vane. What this is, it's a external probe that'll measure the angle of attack of the aircraft, and as you can see here, it will rotate force and also drag exerted by the airflow, and also given the angle of attack indicator, or equal to the angle of rotation. Now you measure the force because that's being extended on it via force sensor. Anyway, you're going to be able to get the angle of attack indicator right there into the cockpit.
Now what you see here is the Pitot Tube. And what the Pitot Tube will do is that it'll measure the total pressure and also the static pressure to determine the velocity pressure from which the air velocity can be calculated or derived. The Pitot Tube, as you notice, it would be pointed towards the airflow. The airflow would be going from your right to the left, and you've got a hole in the Pitot Tube so that the airflow can go inside. Then what will happen is that the manometer will then display the velocity pressure, which would then convert it to velocity. And you would be able to see your indicated airspeed in the cockpit by using one of your flight instruments, as you can see right here in this example.
Now I want to share a story with y'all, and the reason why is because I was very pleased at the end result. It happened when I was teaching some middle schoolers, the Patriots of Sims Middle School. I was going over with them aspect ratio, and what I wanted to also do is go over the function of the Pitot Tube, and the reason why is because they were scheduled to take the aerodynamics module exam while they were taking also the Robotics Education Competition Foundation exam.
Ms. Schmidt had brought her pre-engineering academy to the flight adventure deck so that they could go through the engineering curriculum. And one question that I asked is, if one were flying at 10,000 feet versus at sea level, would your indicated airspeed be less or more at 10,000 feet versus sea level?
I also informed the students that whatever answer they provided to me, they had to defend it. Well, I was glad when one of the students answered that if you're flying at 10,000 feet, your indicated airspeed would be less. And then when I asked him why, he said the reason why is because as your altitude increases, then your air pressure will decrease, which then results in less air molecules, and with fewer air molecules going through the Pitot Tube, then you would end up with a lower indicated airspeed versus if you were flying at sea level. Anyway, I was very proud, and good job to them, good job to the Patriots, and great job, Ms. Schmidt.
Right here is the nose gear, and when I go and try and touch it, I notice a difference between this and also the fuselage, which you see my hand sort of banging. By the way, when you're pre-flight aircraft, you do want to move things around just to make sure that it is secure, because the last thing that you want is that for it to not be secure while you're on the ground, and then you take off and then something falls off. Looks like this landing gear is made out of steel, which is a lot harder than aluminum. Now, a question for those viewing is, why would they use steel instead of aluminum on the landing gear? That is something which we can definitely answer at the end. And what are the components that make up steel? Because when you take in any engineering exam, you will have to answer that question. The next item that we'll go over will be a little bit about the engine. What you can see right here is the intake, which leads to a turbine engine. And also notice there is a difference in the metals. Now, when you end up becoming an 8th grader and going out to the flight adventure deck, we will go over aircraft engines with you, in which you'll have an opportunity to practice and apply Boyle's law, Charles's law, and also apply the nature of science by forming a hypothesis. Right here is the main landing gear, and again, why would we use a steel instead of another metal for this? Okay, and we do notice a difference when we're tapping on the aircraft. The next area that we'll go over on the aircraft will be the wings. Now notice a difference in the materials that are used. Materials used are aluminum, graphite epoxy. At the wing root, which you can see in the diagram, you also have titanium. And you also have a combination of other metals. Now, one thing that's related to science is that anytime you combine metals, you end up a different metal which now has a different capability. And when you have 2 or more metals, that will be an alloy. What you see here is the top of the wing. And we mentioned earlier that at the wing root, you do have titanium. And then on the other surfaces, you have graphite epoxy. And you also have aluminum. Now, why would you end up using different metals on the wings instead of iron or steel? What would that reason be? And we will cover that at the end. I'm noticing a difference, and the flight surface that we see here is the aileron. And the motion that the ailerons would create or cause would be roll. And anytime you want to turn the airplane to the right or to the left, then that is what is caused by your ailerons. This is the back side of the wing, which you can see the ailerons.
This is the front of the horizontal stabilizer.
Notice the top surface of the horizontal stabilizer.
This is the back
of the horizontal stabilizer. The flight surface that you see right here is the vertical stabilizer. And to the left of the number 1, you see a difference in the paint scheme. The lighter color is the rudder, and that is similar to the rudder on the ship. And the motion that will provide would be yaw. What you see here is the tailpipe of the aircraft. And this is where you would see the exhaust of the jet coming out. One question that I like to ask our 8th grade students is to be able to explain Newton's third law as related to the aircraft engine and also the tailpipe and the exhaust. What I would like to hear from them is that Newton's third law states that for every action, there's an equal and opposite reaction. And what I would like to see them explain or hear them explain is that the exhaust of the aircraft is going to go backwards, which is evidence of the thrust, which is now making the airplane go forward. So the exhaust goes backwards, the thrust, and the airplane goes forward. Newton's third law. Now notice that the materials of the tailpipe is made of steel. Why would they make it out of steel and not aluminum?
We know that the tailpipe would get hot, and these are turkey feathers.
What you have right here is the arresting hook. And what happens is that prior to a carrier landing, they're going to lower down the arresting hook. This way, this hook right here can catch one of the arresting wires and stop. And it's actually basically a controlled crash, and the reason why is the approach speed, depending on the aircraft, let's say it can be anywhere from 130 knots airspeed or more. What you see here is another engine. Notice this is a dual engine aircraft. The advantage of a dual engine aircraft is if you lose one engine, then you've got the other in which you can get back to the ship, to the aircraft carrier. What you see here again is the horizontal stabilizer. Now on the left side. Here you see the top, and you also see the bottom. The left gear, again, why is this here made out of steel and not something like aluminum? This is the left intake for the other engine. There are two engines on this aircraft, and once the aircraft engine comes on, you definitely do not want to be standing here. The reason why is that you will get sucked in. Now, isn't that exciting? Walking around the aircraft, a real live Blue Angel aircraft that had flown before. It had flown with the Navy's flight demonstration team. What we're going to do now, though, is go ahead and review some of the items which I had covered with y'all. What are 3 advantages in using alloys on an aircraft? Now let's answer the question on why it's advantageous in using those alloys. One is that now you end up with a lighter weight in manufacturing the aircraft. You're probably wondering, though, why would that be an advantage? The reason why is with an aircraft which is not as heavy, the aircraft would now require less fuel. Now you're probably still wondering, how's that an advantage? Well, since it's lighter, you can add more fuel so that the aircraft can fly longer and farther. Or you could add more passengers in the case of a commercial aircraft, the airlines. Or you could add more bombs, or a combination of any of the above.
That is one reason why you want to use alloys, which are much lighter in weight.
Another advantage,
the alloy is much stronger. As an example, when you combine iron and carbon fiber, you end up with steel, and steel is much stronger than iron. Another question is, why would you use steel on the tailpipe instead of other metals? Well, use some critical thinking with this. As you know, the tailpipe is where you saw the exhaust of the jet coming out. Now, wouldn't this get very hot? Yes, it would. The melting point for steel is more than double the melting point for aluminum. Steel is also much stronger than aluminum and can withstand the heat generated by the exhaust. Why would you use steel on the arresting hook instead of another material? Remember, in a carrier landing, the arresting hook will catch a wire to enable a full stop landing. Steel is needed for its strength. This way, this tail hook does not break when it hits the carrier deck and catches the wire, and then the aircraft can have a successful arrested landing.
one other answer to a question that I asked you is, what are the metals which make up steel? The answer to that is carbon and also iron. And what's the advantage of mixing carbon and iron to get steel? The answer to that is that there would be less susceptibility to corrosion, oxidation, and also rust. And as a reminder, the reason why you end up using
steel
on the landing gear is because of the impact of the aircraft when it lands on the carrier deck or during any other landing. The last thing that you want to have happen is for the landing gear to collapse. One other question. The F-35 Lightning uses titanium on the landing gear. Why would you end up using titanium on the landing gear instead of steel? And which one would have less susceptibility to oxidation, corrosion, and also rust? Well, the answer to that is titanium. And the reason why they now use titanium, again, it's a stronger metal than steel, and it is also lighter and much more resistant to oxidation, corrosion, and rust than steel. Thank you for investing your time in watching this video. If you would like similar activities, we would look forward to serving you and your students on a field trip at the Flight Adventure Deck. And on a similar note, let us know what math, science, technology, or engineering topic you would like for us to deliver for you, which we can possibly make in the future. And we would enjoy delivering content which would help serve you and your students. By the way, if you ever drop by the Naval Aviation Museum, you're welcome to my office at the Flight Adventure Deck. You come by, then I will definitely host you for lunch at the QB Bar Cafe, and that would be on me. One final item, I ask that you please like, comment, subscribe. If you're watching this on the Escambia County School District Science YouTube channel, or on any other social media method which this would have been distributed to. I look forward to seeing you next time and also serving you. Ciao.